Exactly. Okay. Well, good. I didn't realize they gave you a law, so you're good. You're good to go. All right. Yeah, it's 10:30. All right, guys. Welcome back. My name is Matt Levin from One Connection Media Group here in Columbus, and I am a member of the Ohio Broadcast and Multimedia Technology Conference Planning Committee. Hope you had a chance to refill your coffee and visit with some of our exhibitors. This is our multimedia breakout session titled Wireless Microphones in the Post-Repack World, which will be presented by John Muldrow with Lectrosonics. John is a Central U.S. sales manager and has worked for Lectrosonics for 28 years. He provides support to Lectrosonics customers and hits the road 2 weeks every month, visiting not only with dealers but also end users with install problems. John's experience and years in the business qualifies him as an advocate in any subject related to audio. We're delighted to have John here to talk about how the wireless mic industry is preparing for the post-repack world. Please welcome John Muldrow.
Thank you. So the gist of this talk is just to kind of educate people what's going on in the post-repack. We have plans as a manufacturer, as do most other manufacturers, as far as providing equipment for wireless microphones, IFB, E&G equipment, that sort of thing. So just to give you an overview of who we are, maybe some of you, Deb, I know you know us because you've bought quite a bit of our gear, but some of you may not know who we are. Lectrosonics has been in business since 1971. We've been making wireless mics since 1975. So with that, I'll start with a little bit of an overview. So Lectrosonics in 2018, we introduced a bunch of new equipment that falls either in VHF or in what we call Block 941 outside the UHF television spectrum. So that's some of the changes that we have with our equipment line. But also, too, there is a new what's called ETSI mask requirement that has gone into effect as well, starting last month in October. So in Europe, by the way, ETSI, ETSI stands for European Telecommunications Standards Institute. It's a nonprofit entity set up in France that made recommendations on how to make our current spectrum, which, as you know, is just a giant real estate map, more efficient. So this all ties into the repack, the consolidation of spectrum into a much smaller space, okay, which has been a concern to everybody. So two things have happened with Lectrosonics in 2018. We released a bunch of new product, either in high band VHF or in what we call Block 941, which covers 940 to 960 megahertz, just outside of the, this. Basically, if you're familiar with that spectrum, it's the STL allocations have been expanded, and so now we can put wireless microphone equipment up in there. As a Part 74 user, you are allowed to use that equipment up there. The equipment does not actually tune into the STL allocations, so that will allow you to use the equipment. There's no broadcast, and there's no broadcast television up there, and you're not tuning into the STL allocations. So we'll talk about the updates in Spectrum. We'll talk about real-world applications for the gear, and emerging technology. What's going to change in the future. So with that, I'll just talk about a little bit about Lectrosonics in general. As a company, we've been in business building wireless mics for more than 40 years. And we are known in broadcast and film, but we're not known as well outside those industries. So has everybody here heard of Lectrosonics in the past? I mean, some of you are customers, so I'm going to say the majority of you probably know who we are, right? So, but we've won, there's a lot of the production sound mixers that use our equipment have won Academy Awards using our gear. And I'm going to say probably about 80% of feature film production uses our gear. A lot of it, pretty much the same amount in episodic television. I've been on the sets of numerous episodic TV shows where they're using our gear. So it's we've got clout in that industry. So Just to talk also a little bit about our achievements, the two engineers co-developed, Dave Thomas, who's at the podium there, and the other gentleman just to his left, developed what we call our digital hybrid technology. We use a modified FM carrier to carry 24-bit digital audio. That was patented by us, and they received a technical achievement award from the Motion Picture Academy for that gear. So that was something we're very proud of, and I like to emphasize that. We've also developed some other digital platforms as well. We are all digital in all of our wireless equipment is using proprietary digital technology nowadays. So there's no analog gear left anymore. Theater markets, same situation. So Broadway theater market especially, some of your major productions like, as you can see here, Lion King, for instance, Frozen, some of those Broadway productions. By the way, they use a huge amount of wireless for these productions. There's anywhere from 40 to 50 channels of wireless in a theater next to another theater that's about 40 or 50 channels of wireless, so on and so forth. So it's crucial that you have equipment that is relatively free of intermodulation. So if you're wanting to do large channels of wireless, we can do that. So just to give you an overview of what we can do. So let's talk about the nitty-gritty here. So we've seen a lot of changes. 20 years ago, when we had analog television, and every TV station was just one channel occupying a 6 megahertz bandwidth, we had plenty of spectrum to work with. We had 400. It was basically went from 470 to 806 megahertz. You could use wireless mics, and I know when we started building frequency agile wireless microphone equipment in the 90s, we had distinct 25 megahertz frequency ranges starting at 470 and going up to 806. So they were blocks 470 all the way up to block 29. That was our nomenclature. So you may recall, of course, in 2009, we lost the 700 megahertz. 700 to 806 went away. So everybody who owned equipment in that wireless microphone equipment had to either change it frequency-wise or replace it. There wasn't so much of an issue of having to move television transmitters and that sort of thing, but for wireless microphone users, that was kind of a minor deal compared to what we're going through now. So we went from analog to digital television in 2009. We lost the 700 megahertz to 806. So now, with again the transition that we're going through, we've lost the 600 megahertz spectrum. 600 to 700, 698 basically now has been taken away. So UHF television actually tops out at 608. You have a 3 megahertz guard band, 608 to 611, and then from there it's uplink and downlink sections for T-Mobile. By the way, Dish Network bought some of that spectrum too. I'm not exactly sure what they're going to do with it. They haven't really said anything. So it's mainly been T-Mobile, the telecom, that is making hay with that and making investments in a phone network. So has anybody here received a letter from T-Mobile indicating that they're, what we call a 90-day letter, that they're going to be getting, that their cell sites are going to be turned on, and if you have equipment in that frequency range, you're going to be knocked off the air? Has that happened yet? It's happening in the rural areas now. So the bigger areas are going to be last. So cities like Columbus or Chicago, those will be the last areas where they turn on their cell sites. But already in the rural areas and in the smaller television markets, I'm getting we get calls from engineers saying, "Oh man, we just got the 90-day letter from T-Mobile. We have a bunch of equipment above 600 megahertz. What do we do?" So, and that depends. It depends on how old the gear is. Newer equipment can be reblocked at our factory. But if it's too old and we don't build the RF boards anymore, and we don't meet the current ETSI mask requirements, you may just have to go ahead and replace it. So we handle that on a case-by-case basis. So any questions so far about that? So that's sort of an overview of what's going on. By the way, if you want to know there are 4 distinct frequency ranges in the T-Mobile frequency spectrum that they use. So if you get a letter saying, well, we're going to get cell sites B, C, and E, or B, C, D, and E turned on. Well, what does B, C, D, and E mean? Well, there's information, I can email it to you, for instance, that covers the frequency ranges of each one of those cell sites. So if you need to know what they are, we can certainly provide that info. T-Mobile has been very helpful in that respect. So now we're in this situation where we've lost above 600 megahertz to 698. We're now UHF TV is 470 to 608. So wireless microphone spectrum shares UHF television. We are we co-share that. We're a secondary user of that spectrum. So we build equipment in the 470 to 608 range, and typically our newer equipment is wideband tuning, has wideband tuning capability. So there's a block A1 and a B1. A1 covers 470 to 537 megahertz, B1 537 to 608. So between those 2 blocks, we cover the entire UHF TV range. We also have some equipment, IFB equipment, that'll tune 470 to 608 continuously. There's also high band VHF gear in the 174 to 216 megahertz range available. IFB right now, but we're also planning to build wireless microphone equipment. I'm not exactly sure when that's going to be ready. And then there's a block 941, which is 940 to 960, as I talked about earlier. So we get a lot of questions about, are you going to build equipment in the 1.9 gig range or 2.5 or 5 gigahertz? And the answers to those questions is we've decided not to do that. Now there's some competitors out there that are looking at that and are actually offering equipment in those ranges. The problem is that's shared spectrum. So 1.9 gig is the DECT, the digitally enhanced telephone. Those you can go to Costco and buy like a 4-phone package that operates in that 1.9 gigahertz spectrum. So DECT is shared spectrum, and there are some competitors that are going to be building equipment in that range, but we decided not to do that because you'd run into all sorts of it's sort of the Wild West of frequency allocation, and our customers expect solid RF performance, and it's kind of hard to do that when you don't know what you're going to be up against in that spectrum. Same with 2.5 and 5 gig. Believe it or not, there is wireless microphone manufacturers making equipment in 2.5 and 5 gig, but guess what? You've got, everybody has one of these, right? These all want to connect to something. So they're going to cause some interference issues for sure. So all of that spectrum, there's even a 6 gigahertz allocation that could be potentially used for wireless microphones. Again, shared spectrum. But here's the other issue. As we go up higher in frequency, the wavelengths get smaller. It requires more power to send that information over a given distance. So now you're looking at a transmitter that has a very short battery life. I mean, we obviously can't make the transmitters big. People want small, right? So people keep asking, we need smaller and smaller and smaller. We've tried to respond to that, and we have equipment that weighs 2.3 ounces in some cases with a rechargeable battery. But the big issue is still is going to be battery life. Trying to get enough power to send that, to get any kind of decent distance. So, and as you know, if you're an engineer and you've worked with microwave links, you know that becomes very directional, very line of sight, very directional. So those are the problems that you run into. So for us as a manufacturer, we're not going to go above the block 941. 940 to 960 would be the highest that we go. Well, there is some specialized equipment built by us in the ISM band in the 902 to 928 megahertz spectrum. That's usable for certain things. Generally, wireless audio is what we use that for, not necessarily wireless microphones, but we do have that spectrum available. So So just to give you an idea, we talked about T-Mobile. This map is, these maps become quickly outdated, but this just gives you an idea. T-Mobile started in the rural areas first, and then they're spreading out to the larger, metropolitan areas last. So cities, again, like Columbus or Cincinnati or Chicago are going to be, those will be the final pieces of the puzzle that fall into place. The rural areas are getting set up first. In fact, many rural states, like South Dakota, North Dakota, my state, New Mexico, most of that is already up and running. It's like Albuquerque, where I'm from, is going to be the very last city that has T-Mobile cell sites turned on. Pretty much 30 of the 33 counties in my state now have T-Mobile cell sites active above 608 megahertz. So, so it's happening. The transition's happening pretty quick. And supposedly, from what I read, this last quarter of 2018 is where you were going to see a big push to get as much of that stuff up and running as possible. So they want to maximize that investment. They've spent billions so far. Even they made a big investment buying the spectrum and then investing in all the infrastructure. So they want to get that return as quickly as they can. So this is an example of cities and what so these cities, these three cities here, this is all post repack. So we got the current allocations and then what that spectrum is going to look like post repack. And I can run these reports for any city. So if you've got a question, what's my spectrum? I want to buy equipment. I need help. What do I want to use? What block? Do I want to use an A1 or a B1 or a block 941? We can help you make those decisions, and that information is readily available from the SEC. So we can send you a nice color-coded chart that at a glance you can see, oh, okay, this looks like B1 is going to be better. It looks like A1 is going to be fairly occupied. Some cities are it's really going to be a challenge. Denver, Colorado, which you wouldn't think being a city like Chicago, very congested, but actually Denver is close to several other cities. You got Denver, you got Fort Collins, Colorado, you've got Colorado Springs, you've got Pueblo, Colorado. All that whole corridor, they're all very close to each other, and there's very little spectrum in the UHF television left. So for that area, a number of customers are looking at the 940 to 960 megahertz spectrum, or they're looking at high band VHF, because that's where most of the open spectrum is going to be. There's going to be very little UHF TV spectrum open in that 470 to 608. So we've got customers who are looking outside that UHF TV allocation. And we can do that. We're going to have VHF, we're going to have block 941, we can do that. So we've also made, and other manufacturers are doing this too, we have software that allows you to scan and do frequency coordination and that sort of thing. We call our software Wireless Designer. And the Wireless Designer software, and I'm just going to pop my version on my computer up here just for a second. This allows you, it's free, there's no licensing issues, you can download it and use it as a tool. So if you have a bunch of our gear, as well as competitors' gear, it'll work with competitors' product, but Wireless Designer will allow you to scan. If you plug into our receiver mainframe, you can scan, gather all the RF energy that's in your area, and then export that to frequency coordination, and then it will coordinate everything that it sees. And you can add custom channels in there, so if you've got a bunch of Shure Sennheiser gear, let's say, or Sony, that you want to hang on to and you want to coordinate around with, you can plug those frequencies into that software, and it will do that. It'll coordinate everything for you. And I'll have that up and running at my booth, so if you want to see how that works, I'd be more than happy to show that. There are 2 TCP ports for the software, so 2 computers can talk to it simultaneously, so you could have maybe master control or production control running it in the background, or if you're the engineer there and you want to have a copy of it running on your desktop in your office, it's all, it can all be connected on the network. So you can run the software from a remote location and do coordination right there. In fact, I've walked people through that. In fact, I just did that here just a few days ago with an engineer in Wausau, Wisconsin, where he had 5 channels of IFB, 6 channels of wireless, connected it all together on a network, scan, export to frequency coordination, did the frequency coordination, everything worked beautifully. So it makes it really easy, especially in crowded, now Wausau is a rural area, but in the more crowded RF environments, like a city like here in Columbus, that'll make your job easier. So. So yeah, we want to, when we're talking about frequency coordination, if you are, let's say if you're a television station with a news and weather set and the ENG crews and that sort of thing, you definitely want to be able to, you want to include all of your RF sources. So make sure you've got all of your wireless intercom, IFB, studio wireless. If there's people bringing ENG wireless in and out of your building, that's something that you may want to take into account as well. So that's a big deal. So the picture on the far left with the Kansas City Chiefs logo behind there, that's the guy on the right holding up and pointing to the transmitter. His name is Scott Carter. He's the head audio guy for NFL Films. And NFL Films, now that's an organization. NFL does frequency coordination. If any of you have had to deal with the NFL, Deb, I know you're in Cincinnati, you got the Bengals, you probably have a game day coordinator down there that you have to work with before you can even take wireless microphone equipment down into the stadium, right? So that's pretty typical anywhere. NFL Films coordinates typically 40 to 50 channels of wireless per football game. That's a huge operation, by the way. It's pretty impressive how they run all that. All the game information is sent to New Jersey, and all that's put together on a subscription basis for anybody who wants to air highlights of NFL games. They have 70 studios in New Jersey, and Scott is the guy that coordinates all the audio. So, but just to, they're coordinating wireless mics. They've got IFB. They got intercom. The camera with the receiver, the slot-in receiver, the NG receiver. If you're doing, if you're in a major market and you're coordinating with other stations, cover events, that's another issue that you're probably going to run into is frequency coordination among different television stations or different news groups within your city. So there used to be coordinators that would do that, and some cities that's just kind of fallen away. I don't really hear much about that anymore. Deb?
Still have one, but I can't remember his name off the top of my head.
So you do have a coordinator there in Cincinnati. So
There's 2 in Cleveland.
is there 2? Okay.
One over a gigahertz, one below.
Okay. So there's 2. All right.
I'm the guy in Cleveland that's the over one.
Okay. All right.
I'm also the lead NFL coordinator for international games.
Okay.
Scott Carter.
You know Scott very well. Okay. Awesome. So yeah. So in the major markets, coordination amongst the different stations is going to be crucial as well, especially since we just don't have as much spectrum to work with. So that's just kind of a little reminder about including all our sources and working together locally if you can. So just to kind of highlight what we talked about earlier, we can use the 174 to 216 megahertz spectrum. All right, that's high band VHF. That's TV channels 7 through 13. In some markets, VHF has been abandoned completely. I know I used to live in Youngstown, Ohio. That was a all UHF television market, and I think there's going to be one station moving to high band V, but everybody else is going to stay in the UHF spectrum. Some cities, it's a mixture of both. I live in Albuquerque. Everybody likes the propagation that you get, at least in a rural state where I'm from, and Albuquerque covers, it's basically the broadcast center for the whole state. So between transmitters on top of 11,000 foot mountain outside of Albuquerque, as well as translators, I know like KOAT covers a 3-state market. Gary, covets that. Covets that. He's got a 5 kilowatt transmitter on Sandia Peak, and he can reach Arizona, southern Colorado, of course, northern New Mexico. And of course, he's got a bunch of translators too. But it depends on the market. Like a rural market, they like high band V because you get, with 5 kilowatts, you got the bigger wavelengths, you can cover more distance. Chicago, on the other hand, likes the UHF spectrum because they can penetrate the buildings with the shorter wavelengths in the UHF spectrum better. So so it just depends, I guess. Here in Columbus, this area is relatively flat. I know WBNS here has a tower with their transmitter power. I think is a million watts ERP, which is pretty high power, just to cover the greater Columbus area. So and that's UHF. So it just depends on the area, but we will be building equipment in both high band V and UHF. So 470 to 537 megahertz, UHF television spectrum, lower UHF TV. That's what we call block A1. So A1 is 75 megahertz. Wireless microphone equipment as well as IFB is available in that A1 range. B1 is 537 to 608. So I've got customers who bought a combination of both A1 and B1. So between the two, on their news and weather set, let's say they've got, the sweet spot seems to be about 8 channels of wireless on a news and weather set typically. The customers have spread it between 2 blocks so that between the 2 blocks they can cover the entire UHF television spectrum. 902 to 928, I touched on this a little bit earlier. This is what they call the ISM band. It's in industrial, scientific, medical. We don't build wireless microphone equipment in there, but we do build some transmitters and receivers for wireless audio. So there's a 4-channel transmitter and a 4-channel receiver that we build that work in that spectrum. If you're looking to send audio, the transmitter, by the way, is a 1/4 watt. It's a Part 15 type acceptance, so you don't need a license for it. That's kind of there are 3 specific users, so it isn't quite the Wild West allocation that 1.9 or 2.5 or 5 gigahertz has. But if you're looking to send some audio, multiple channels of audio, it's ideal for that. That spectrum is good for that. So I've got a transmitter that does it's called the D4, D4T, D4R. D4T is a transmitter, 1/4 watt transmitter, 4 channels of audio on 1 digital carrier. So we have that equipment available, and that spectrum is available for point-to-point, or sometimes that equipment is used for camera hops, stuff like that. So you can certainly do that. Then I touched on the block 941, so 940 to 960 megahertz is ideal, especially for ENG. There's no UHF television up there, but there is some STL allocations. Our block 941 equipment does not tune into the STL allocations. So it's not an exact 20 megahertz. It's more like 18 megahertz, the spectrum that you can tune across. Go ahead.
What's the issue with descents because you may be around that? I understand you're not on the frequency, but
Right.
we both understand that receivers can't reject it when it's that close.
Well, we've done a lot of engineering as far as making that receiver. The receivers have what's called a tracking front end to keep the Q extremely narrow as you're tuning across, not just in the block 941 equipment, but also in the A1 and the B1 stuff too. The Q is very, very, the selectivity is extremely high. And so it's basically a microprocessor that controls the front end. There's some front end filters that are controlled by a microprocessor to keep the Q selective, to keep the selectivity extremely high. So when you are in a high power adjacent channel situation, it doesn't saturate the front end of the receiver with RF. And that's true even in the UHF, just in general in the UHF television spectrum. Our receivers all have a smart tune function, so they'll tune around those high power RF sections that it finds. So as it's tuning, the smart tune will look at how much, if it sees a 6 megahertz slice of spectrum that is, 1,000 microvolts or something higher, then it will simply tune around it and skip it. So that so your receivers have some intelligibility there. They're intelligent enough to tune around those high power sources, and the tracking front end will keep the Q constant as it's tuning, so you don't lose selectivity. So that generally doesn't become a problem for us in that situation. So the tracking front end is an ideal tool for that. So any other questions? So I touched on the 1.9 gigahertz. There is wireless intercom available in that spectrum. That's a good spectrum for wireless intercom. It's not necessarily mission critical audio. You're not on the air live, where you're having to worry about interference and losing the audio altogether. So the 1.9 gig spectrum is being used by companies like Clearcom, for instance, and HME. There's a couple companies that are producing wireless intercom up there. So it's shared with that digitally enhanced, cordless telephone. That DECT, digitally enhanced cordless telephone is what that is. I don't know. Does anybody own any of those? I used to have some of that stuff at home, but we got rid of our landline, so we just have cell phones, and we don't have any cordless landlines anymore in our house. So it used to be you could go to Costco and buy like a 3 or 4 pack of those phones, and you get a base station and then basically 4 phones you could scatter around your house. But we don't have that anymore. So does anybody have that still? Is anybody using that? There's a couple. Did you? Okay. Yours is it 5 gig? Okay. Yeah, I haven't really kept up with that. I remember it was a big deal when that allocation was created, and it started in Europe first, then came to the U.S. later. But nowadays, I mean, a lot of households don't have landlines anymore, so it's I haven't really kept up with it. We talk about 2.4 gig, so there is some intercom equipment there too as well on the 2.4 gig spectrum. Again, that's ideal. That's not mission critical audio. 2.4 is okay. All right. Let's touch a little bit about frequency coordination. Does everybody understand what intermodulation is between wireless microphones? When we talk about intermodulation in a wireless microphone setting, it's crucial that you check for intermod when you're using multiple channels of wireless. I had a gentleman a few days ago who bought a bunch of wireless microphone equipment and didn't understand that you have to check for intermod. That's that's what that software, that wireless designer software that we talked about earlier, will do. It will go through and check for intermod as well as unusable high power RF sources that we want to tune around. But I had a guy call up and said, gosh, I bought a bunch of this gear, but I have so many RF problems. I said, well, did you do any frequency coordination? Did you check for intermod? What's that? Well, okay, so intermod is the mixing of RF. In a wireless microphone setting, we get the RF being mixed from one transmitter to another, and it's the sum and the difference. So we have RF that can add and create a false frequency, or we can have RF, the difference, to subtract from that and create a false frequency, and that's what this graph is showing. So we have, and it's a problem when you have 2 or more wireless microphone transmitters. Okay, so in this case, our example, we've got 650 to 670 megahertz, and you have a 20 megahertz difference. So we can subtract 20 from 650. So we'll have a intermod problem on 630. We'll have a problem on, of course, on if we add 20 megahertz to 670, we get 690 megahertz, so we'll have potentially an intermod problem there. So it's important when you buy a bunch of wireless microphone equipment that you want to do coordination and check for intermod. Go ahead.
Don't you also have a problem when you take 650 and add the 20 to it?
Right.
Which is also a possibility.
Yeah, it's also a possibility. And
Hits the other one directly.
exactly. So that's why it's important. And because there's so many, you can see just with two systems, how many different combinations of RF problems we're going to have. All right. So it's important. That's why software makes this so much easier. If you had to try to calculate this, you'd probably never. It could run into the millions of calculations. So that's why software really helps in eliminating RF problems due to intermodulation. And then there's different grades of RF of intermod. So we got third order intermod, we got fifth order intermod, we got seventh order intermod. Third order intermod is going to be the worst. That's going to be the strongest signal that could potentially cause interference. Typically intermod sounds like if you're getting like a frying egg type sound coming through your audio, or if it's just completely gone altogether. Those are symptoms of intermodulation. And all RF transmitters create intermod. Actually, all electronic devices create intermod. Nowadays with digital devices, we have all these clocking frequencies internally in these devices. They all radiate RF. In fact, there's an FCC requirement. I forget the type acceptance number, but within 10 feet, it's not supposed to cause interference to other devices, even though it's not a transmitter, okay? It could be a camera, it could be a digital recorder, it could be a switcher, it could be something. But nowadays, all these digital devices radiate RF, so, and we can run into intermodulation because of that. But RF transmitters, like wireless microphones and IFB transmitters, you can get this mixing, the sum and the difference of RF being combined or subtracted from to create intermodulation. Now we can mitigate that a little bit. We put what's called a circular isolator into our transmitters. I'm not sure what other manufacturers do. Everybody's got different ideas on how to do this, but our idea is to use what's called a circular isolator. It's like an RF diode. It's probably the best way to describe it. It allows RF to flow one way out of the transmitter. And normally what can happen with wireless microphone transmitters, you can have RF being fed back into that input of the final RF output, and you get this, oscillating effect going on, and it creates intermodulation, false RF frequencies across quite a bit of a bandwidth, and that could be a problem. So typically low-cost transmitters don't have a lot of intermod mitigation. Higher or more expensive, higher cost transmitters typically do. So one of the ways we mitigate it is to put what's called a circular isolator. And it's a $30 part. It's not cheap. $30 in a manufacturing environment is a lot for a part. So there's different ways to mitigate that, but that's one way we do it. We put those isolators into all of our transmitters to mitigate that feeding back of RF, or creating an oscillator in a sense, to mitigate the intermod problems. So any questions about intermod? So our software, the wireless designer software, will allow you to check for intermod, do frequency coordination with our gear as well as anybody else. There's a button on there, add custom channels. So you can plug in, if you got, Shure, Sennheiser, Sony, whatever, you can add those frequencies in and coordinate around them if you want to do that. Yes?
But you have to also add in the city of Akron trash department, the city of Akron dump trucks, the city of Akron snow trucks, the city of Akron blah, blah, blah. Because guess what? They're running on the 600 meg bottom, the commercial band, and guess what? Their second harmonic is your fundamental. And I've had more trouble, me personally, not between microphones in the system, but snow system. So during the winter, that one is going bonkers, and it's getting overrun. I mean, to the point of it completely obliterates the local audio, and you're listening to the dispatcher to the snow group telling you, go somewhere, telling some truck number to go somewhere, in completely understandable audio. It's not digitally encrypted, it's analog audio. Still a lot of that going on in two-way. And I've had more trouble with that than the 20 wireless microphone system on a stage talking to itself. And that, you can't ignore any of that.
Right. That's why you have to include all RF sources. And some of that may be unique to where you are. Like, you know, like in Akron, you got the
Snow guys down here
the
could
snow
run
guys.
a digital system on 900 meg digital stuff, and
Yeah,
you won't hear it.
right.
Well, what it will do is it can hit you and cause a reduction in your sensitivity. So you're walking around on the stage, and all of a sudden you're dropping out where the other character who's got another channel, they're walking around in the same spots, and they're having no problem. But what it'll show up as is a reduction of your ability to hear the signal. You may not hear any audio.
Right. Here's another issue that you run into at times. You run into this more on film sets and episodic television, but you got wireless video being used, right? Because nowadays they don't use film anymore. Everything's electronic. You have to coordinate around the wireless video systems. So that's something that's come up in the last decade or so. So yes, it's important, it's crucial that you include all RF sources if you can. You know, and sometimes you don't know all of them. But oh, are we out of time? Yeah. Oh, I'm sorry. Okay. All right. I think we're here.
Thanks, John, for a great session. A recording of this session, along with the presentation, will be available in the Engineering Conference archives of the OAB website in the next few weeks. Our next multimedia session will be in this same room at 11:15, and will focus on 5G technology and the future of remote broadcasts.